So now we're going to move on to exercise 1D, and this is about simultaneous equations. So basically in the first part we just need to solve some simultaneous equations. So this is the first system. And what we will do is we'll just, because they're both y equals, we can say that one's equal to the other, rearrange, and then we can factorize. And then we'll get two solutions for x. And individually we need to solve for their respective y's. So we get, we can answer in the form what minus 3, 9, and 2, 4 is our answer. This one's a bit different, and we need to figure out a different way to solve these. What I would do is do it by substitution. I'd rearrange to get y as the subject, and then I would substitute that y into the second equation. And then I can just keep doing algebraic manipulation. And then eventually I'll get a quadratic, which I can solve very easily. And this factorizes as well, very lovely. So x will either be minus 8 or x will be 2. That means y will be, let's see. Okay, 6 minus x over 4. So 6 minus 8 is plus 8 over 4. That's 14 over 4, which is 7 over 2. Or y can also be 6 minus 2 over 4, which is just equal to 1. So our answer's of the point minus 8, 7 over 2, and 2, 1. And we've got a similar sort of thing over here. Here, and we got a similar thing, but here, to be honest, I'd probably just substitute in x, because it's just slightly easier. But seriously, up to you. And those hundreds will eliminate. So now we see that y is equal to 0 or y is equal to 6. And then we need to figure out our x's. So x can be either 3 times 0 minus 10, or x can be 3 times 6 minus 10. This will be just minus 10. This one here will be 8. So the points will be minus 10, 0, and 8, 6. Now for D, we have, y equals 3x minus 1, then 8x squared minus 2xy equals 4. And instantly we will substitute that y for 3x minus 1. And so that's equal to 4. squared minus 6x squared plus 2x equals 4. 2x squared plus 2x minus 4 equals 0. So that just becomes x squared plus x minus 2 equals 0. And that's x plus 2, x minus 2 being equal to 0. Sorry, not x minus 2, that's just x minus 1. So that will be x equals minus 2, x equals 1. And then our y will be 3 times minus 2 minus 1, so that's minus 7. And then y is 3 times 1 minus 1, which is just 2. So the intersections, or the solutions, are negative 2, negative 7, and 1, 2. E. X minus 2y equals 6. X squared minus 4xy equals 20. X equals 2y plus 6 by that rearrangement, and then we'll substitute that in for all our x's. Get 4y squared plus, 2 times 12y, so that's 24y minus 8y squared minus 24y. Hope that's right. Yeah, looks okay to me. So we get minus 4y squared on this side. Those will cancel out, leaving us with 20. Except that is giving false solutions. So let me just go back there. I'll move this around and I'll properly do this. 4y squared plus 24y plus 36. Sorry, being a dingus. Minus 8y squared minus 24y equals 20. Those 24s will eliminate, and we'll get minus y squared. And then we get 20 minus 36, which is minus 16. Y squared will equal 4. Y will either equal 2, or y will equal negative 2. And then x is 2 times 2 plus 6, which is 10. Or x equals 2 times minus 2 plus 6, which is 2. So we get 10, 2 and 2, minus 2. F 4x minus 3y equals 5. X squared plus 3xy equals 10. And let's see, I think my instinct is just to get the y. So 3y equals 4x minus 5. Y equals 4x minus 5 over 3. So x squared plus 3x, 4x minus 5 over 3 equals 10. $12x squared minus 15x over 3 equals 10, and we could factorise that out to make it only a 4x squared minus a 5x being equal to 10. 5x squared minus 5x minus 10 equals 0. Divide everything by 5. Just make it a bit easier for ourselves. So that'll give us x minus 2, x plus 1 equals 0. So that means x will either equal 2 or x will equal -1. And y is equal to 4 times 2 minus 5 over 3. So that's 1. Or it can equal 4 times -1 minus 5 over 3, which is -9 over 3, which is just -3. So the answer will be 2, 1, and -1, -3. G. 2x plus y equals 8. xy equals 8. Y equals minus 2x plus 8. X multiplied by minus 2x plus 8 will then equal 8. Expand, minus 2x squared plus 8x equals 8. 2x squared minus 8x plus 8 equals 0. X squared minus 4x plus 4 equals 0. X minus 2 squared equals 0. Therefore, x must equal 2. Then, look, y is just going to be 8 over x, which is 8 over 2, which is 4. So the answer is 2, 4. And you could write this as x equals 2, y equals 4, because there's only one solution. It won't be ambiguous what you're talking about and which goes with which. The next one is 2y minus x equals 5 and 2x squared minus 3y squared equals 15. X equals 2y minus 5. 2 multiplied by 2y minus 5 squared minus 3y squared will equal 15. So that's 2 multiplied by 4y squared minus 20y plus 25 minus 3y squared equals 15. That's 8y squared minus 40y plus 50 minus 3y squared equals 15. 5y squared minus 40y plus 35 equals 0. Y squared minus 8y plus 7 equals 0. Y minus 7, y minus 1 equals 0. So y equals 7 or y equals 1. X will either equal 2 times 7 minus 5, that would give you 9. Or it could equal 2 times 1 minus 5, which would give you -3. And so that's why your answer will be 9, 7 and -3, 1. Then for I, we'll just it's the same thing as before, essentially. Two y will equal 6 minus x. So y will equal that over 2. So then x squared plus 6 over 2 squared plus 4. Does that say 4xy? Yeah, 4x. So on the top we get x squared minus 12x plus 36 over 4 plus, maybe we'll do a minus 4x squared minus 24x. Just be careful about negative signs here. And I say that and I've probably made a mistake. But we'll find that out shortly if that's the case. I like to just get rid of fractions. Makes things easier to deal with. And also don't like having the lead coefficient be negative. It makes it more annoying to factorise. Small stuff. Right, so we've gotten to this point and it looks like it factorises. And I think I may have gone away with all that and have generated the correct solutions. And remember, we're just substituting it back in here to get the y's. So then we have 2 and 10 minus 2. J. 5x minus 2y equals 23. X squared minus 5xy plus y squared equals 1. 2y will equal 5x minus 23. Y will equal 5x minus 23 over 2. So we are rearranging to get y as the subject. And that means we can just substitute that into our second equation. And now we need to try and expand this. Five x squared over 4, which is equal to 1. Okay, now we'll get rid of these fractions. We don't like fractions. And now let's see if we can figure this out. Right, so at this moment we have, this will give us minus 46 squared, but then we're adding back 25. Minus 21x squared. So x squared will just be equal to minus 525 over negative 21. So that's just 25. So x will either equal 5 or x will equal minus 5. Now y is just 5 times 5 minus 23 over 2, which is, that's just going to be 1. Or it will be equal to 5 times minus 5 minus 23 over 2, and that will give us negative 48 over 2, which is negative 24. So you get 5, 1, and negative 5, negative 24. Okay, x minus 4y equals 2, xy equals 12. Okay, x equals 4y plus 2, so xy will equal 4y plus 2, and then we'll multiply that by y. That's 4y squared plus 2y minus 12 equals 0. 2y squared plus y minus 6 equals 0. And let's see if we can factorise this. AC equals minus 12. So y will either equal 3 over 2 or y will equal minus 2. And x is just equal to 12 over y, so that's 12 over 3 over 2, or 12 over minus 2, giving us negative 6 and 8. So the points will be 8, 3 halves, minus 6, minus 2. L, 2x minus y equals 14. Y squared equals 8x plus 4. Y equals 2x minus 14. 2x minus 14 squared equals 8x plus 4. 4x squared minus 56x plus 196 equals 8x plus 4. 4x squared minus 64x plus 192 equals 0. So that's x squared minus 16x plus 48 equals 0. That's x minus 8. Oh, no. That's x minus 12, x minus 4. X equals 12 or x equals 4? Hang on, no, not quite. No, yeah, that's right, yep. And then y will just equal 2 times 12 minus 14, so that's 10, or y will equal 2 times 4 minus 14, which is negative 6. So we've got 12, 10, and 4, negative 6. Let's keep on going. 2x plus 3y plus 19 equals 0. 2x squared plus 3y equals 5. Ouch. Okay. Right. 3y equals minus 2x minus 19. Y will then equal 2x over 3 minus 19 over 3. And then we can substitute that into the next one by doing 3 minus 2x over 3 minus 19 over 3. Which will equal 5. Now notice, because these two are literally just the same, we didn't have to really do that. I just did that to kind of emphasize. So, and that's why I left it in that form, kind of. 2x squared minus 2x minus 19 will equal 5. 2x squared minus 2x minus 24 equals 0. X squared minus x minus 12 equals 0. X minus 4, x plus 3 equals 0. So x is either equal to 4 or x is equal to negative 3. Then, what does y equal? And again, this is why we kind of had to do that rearrangement of y. 2 over 3 times 4 minus 19 over 3, which gives us negative 9. Then if we do the same for x is equal to negative 3, we'll end up with negative 4/3, which was negative 13 over 3, I think, yeah. Yeah, negative 4 and 1/3 is negative 13 over 3. So we've got 4, negative 9, and negative 3, negative 13 over 3. N, x plus 2y equals 5, x squared plus y squared equals 10. X is negative 2y plus 5, and so this will mean we can substitute that in. 4y squared minus 20y plus 25 plus y squared equals 10. 5y squared minus 20y plus 15 equals 0. Y squared minus 4y plus 3 equals 0. Y minus 3, y minus 1 equals 0. So y is either equal to 3 or 1. Now x in this case will either be minus 2 times 3 plus 5, which is minus 1, or x is minus 2 times 1 plus 5, which is 3. Right, so yeah, you want to make sure you don't get your negative signs mixed up. So we're doing a 3 and a 1, and then a negative 1 and a 3. Okay, got it. Now for O, x minus 12y equals 30, and then 2y squared minus xy equals 20. X is equal to 12y plus 30. 2y squared minus 12y plus 30 times by y is 20. And that means 2y squared minus 12y squared plus minus 30y equals 20. Negative 10y squared minus 30y equals 20. 10y squared plus 30y minus 20 equals 0. Y squared plus 3y minus 2 equals 0. Y minus 2. Oh, hang on. Y plus 2. Y plus 1. Oh, sorry, no, I shouldn't have, that shouldn't be a negative 20, that should be positive, yeah, equals 0. And so y will either be equal to minus 2 or negative 1. And then x will just be minus 2 times 12 plus 30. So that's just 6, or will be 12 times minus 1 plus 30, which is just equal to 18. So you've got 6 minus 2 and 18 minus 1. Whew. Now that was just the first question. Now we'll go on to question 2. Right, sum of two numbers is 26, product is 153. So x plus y equals 26, xy equals 153, y equals 153 over x, x plus 153 over x equals 26, x squared plus 153 equals 26x, x squared minus 26x minus 1 plus 153 equals 0. Now this will just factor as x minus 9, x minus 17 equals 0. So x could equal 9 or it could equal 17. Now the good thing about this is because we would use this x plus y thing, or xy equals 153, to get the y value, you'll end up with y is 17 for that one and y equals 9 for that one. And because it just wants to know what the two numbers are, then we just say the two numbers are 9 and 17. But now it's saying the product's actually 150. Sum is still 26, but the product is 150. So x plus y equals 26, and then xy is 150. So y is just 150 over x, and then so x plus 150 over x equals 26. So x squared minus 26x plus 150 equals 0. And this we may want to do a bit of either quadratic formula completing the square. I'll just complete the square because it's looking fairly easy to do so. And yeah, you can notice that we're getting surds here. So plus or minus root of 19. So x the numbers are going to be 13 plus or minus root 19. So that's 13 plus root 19 or 13 minus root 19. Question 3. Perimeter of rectangle is 15.8 centimeters. Area is 13.5 centimeters squared. Now we need to find the lengths of the sides of the rectangle. xy will equal 13.5 because base times side. The perimeter will be 2x plus 2y. That's 15.8. Y is just equal to 13.5 over x. So we'll substitute that in. Two x squared plus 27 equals 15.8x. Minus 15.8x plus 27 is equal to 0. I am not down to do the extra steps of factorising now, so I'm just going to jump straight to the quadratic formula. And note that we're probably only going to take the, well, actually no, I think it'll have two positive roots. Right, so one of them we get a solution of 5.4, and then the other one, when we take negative, we get 2.5. So the side lengths are 5.4 cm and 2.5 centimeters. Next question. Right. The sum of the perimeters of two squares is 50 centimeters. Sum of areas is 93.25 centimeters squared. Now we want to find the side length of each squared. Okay, so the perimeter of a square is just 4x. So 4x plus 4y will equal 50. Sum of the areas is 93.25. So that's just x squared plus y squared equals 93.25. 4y will equal minus 4 plus x plus 50. Y will then equal minus x plus 50 over 4, which is minus x plus 25 over 2. Right, substitution time. So that's 2x squared minus 25x plus 63 equals 0. Whew, okay. I'm just going to do the quadratic formula at this point. Okay, x equals 25 plus or minus square root of 25 squared minus 4 times 2 times 63 over 2 times 2. So that's 25 plus 25 squared minus 4 times 2 times 63 over 4. So we get 9 and 3.5. So side lengths are 9 cm and 3.5 centimeters. And we'll keep going. 5. Okay. Sum of circumferences of two circles. Is 36 pi centimeters. Sum of areas is 170 pi centimeters cubed. 2 pi x, we should say, trying to find the radius of each circle. So 2 pi x plus 2 pi y equals 36 pi. So that's just 2x plus 2y equals 36 because the pi's will cancel. Sum of areas will be pi x squared plus pi y squared equals 170 pi. Again, just get rid of those pi's. And we'll do a substitution, and I can further simplify this with that. So x squared plus minus x plus 18. I've just done that substitution, that rearrangement here. So x squared plus x squared minus 36x plus 324 equals 170. 2x squared minus 36x plus 154 equals 0. X squared minus 18x plus 77 equals 0. And this is easily factorised. So the two radii will be 11 cm and 7 cm. Okay, cuboid is 5 by x by y. X plus y equals 20.5. Volume is 360. So we need to find x and y. So the volume of a cuboid is just the dimensions multiplied by each other. 5xy will equal 360. That means xy will equal 72. That means y will equal 72 over x, and so x plus 72 over x will equal 20.5. X squared plus 72 equals 20.5x. 2x squared minus 41x plus 72 equals 0. AC will be 144. And I'm going to skip. I'm actually not going to try and factorise this. I'm going to skip to quadratic formula. X will be think somehow I've botched this. I think I've done something wrong here. I may have just typed it in the calculator wrong. Oh, I haven't doubled that. Okay, so I get equals 4.5, and then y will just equal 16, and obviously it can be the other way around. Right. 7, we've got, okay, let's see if I can replicate this diagram. You've got a bit of a semicircle, a hemisphere, on top of a cylinder. From top to bottom, full way, 18 cm. But then the height is just h. And then you've got a radius, r. And it's given that the surface area is 205 pi centimetres squared. So we need to figure out what r is and what h is. Right. So the total surface area will equal 4 pi r squared over 2, because it's a hemisphere. And that cylinder, you'll get one will be pi r squared, and the other will just be 2 pi r h to account for that circumference and height that makes that rectangle when you make that net. And we're saying that this is just equal to 205 pi. Now, from this point up here is also just going to be the radius. So h is also 18 minus r. So we can rewrite the surface area as being, well, if we simplify it a bit more, and now we'll just get rid of all the pi's. 3r squared plus 36r minus 2r squared equals 205. R squared plus 36r minus 205 equals 0. Sorry, 3. Oh, no. So r will equal 5 because we only will take the positive. And then h will just be 18 minus 5, which is 13. So r is 5, h is 13. 8. So we're saying the question says that the line y equals 2 minus x intersects 5x squared minus y squared equals 20 at A and B. So when we want to find intersections, we just do simultaneous equations. So we can substitute in that y. And then we expand. And we get a quadratic equation like that. And then you can just solve it by factorization. And so x will either equal minus 3 or 2. And then we just do y equals 2 minus 3, which is just 5. And then, or it can equal 2 minus 2, which is 0. So A and B are at minus 3, 5, and 2, 0. An order isn't really specified, and which one is which doesn't particularly matter for part B, which is finding the length of the line AB, which is the same as the distance between A and B, and formula for distances, like Pythagoras. So that's just 25 plus 25, which is root of 50, which is 5 root 2. Moving on to question 9. It's a similar sort of thing. 2x plus 5y equals 1 meets curve x squared plus 5xy minus 4y squared plus 10 equals 0 at A and B. And we need to just find the coordinates of A and B first. So, okay, let's rearrange this. Two x equals minus 5y plus 1. X equals minus 5 for 2y plus a half. Now, then if we substitute that in for x, Right, and then we'll expand all this. I certainly hope I've done that right. Ooh, okay, this is rather difficult for me to figure out. I know those will eliminate. So now we'll just do 25 over 4 minus 25 over 2 minus 4. That's minus 41 over 4. Oh, y squared. Plus 41 over 4 equals 0. So y squared just equals 1. So y will equal 1 or y will equal minus 1. Is this, I mean, I'll just, for pedantic's sake, like that. And then we'll continue. Equals minus 5 over 2 times 1 plus half, which will just be minus 2. Or x can equal minus 5 over 2 times minus 1 plus half. So that's 5 over 2 positive plus half, which is 6 over 2, which is 3. So A and B are at minus 2, 1, and 3, minus 1. And part B wants us to find the midpoint of line AB. So the midpoint of AB is just equal to minus 2 plus 3 over 2, comma 1 minus 1 over 2. So that is half 0. The line 7x plus 2y equals minus 20. And it's intersecting the curve. Equals 0. That's a circle equation. And that's at A and B again. Find length of line AB. Right, the first thing we need to do is find A and B. And what we're going to do is we're going to complete the square on this one. We're going to say, okay, it's x squared plus 4x plus y squared plus 6y, and it is equal to 40. And then x plus 2 squared minus, honestly, no, we probably won't have to complete the square. It may just, it could make it easier, but honestly, I think we'll just get straight into it. Okay. 2y equals minus 7x minus 20. Y is equal to minus 7 over 2, x minus 10. So x squared plus minus 7 over 2x minus 10 squared plus 4x plus 6 times minus 7 over 2x minus 10 minus 40 is equal to 0. 49 over 4x squared plus 70x plus 100 is 4x minus 21x minus 60 minus 40 equals 0. Eliminate there. So we get 53 over 4x squared plus 53x equals 0. And then if we factor 53 out, we get x over 4 plus 1 being equal to 0. So x is either equal to 0 or x is equal to minus 4. And then for those respective ones, you get minus 7 over 2 times 0 minus 10, which is just minus 10, or that, which is, it's positive, so 14 minus 10, which is just 4. And then the distance between A and B is just going to be 4 plus 10 squared plus minus 4 squared. Which is root of 212, which is 2 root 53. Because this root of 212 is actually 4 times 53. And that means you just can remove that 2 to make it 2 root 53. Right, question 11. It's asking for 7y minus x equals 25 cuts x squared plus y squared equals 25 at A and B, and it wants the perpendicular bisector of AB. Right, we better get into it. X is just equal to 7y minus 25. So 7y minus 25 squared plus y squared equals 25. 49y squared minus 350y plus 625 plus y squared equals 25. 50y squared minus 350y plus 600 equals 0. Y squared minus 7y plus 12 equals 0. So y minus 3, y minus 4 equals 0. Y equals 3, y equals 4. X equals 7 times 3 minus 25, which is minus 4. Or it can be 7 times 4 minus 25, which is 3. So A and B at 3, negative 4, 3, and 3, 4. And so now we can look at getting the perpendicular bisector. The gradient from AB is 4 minus 3 over 3 plus 4, which is 1/7. So the perpendicular gradient will be -1 divided by 1/7, which is just -7. So y minus y1 equals mx minus x1. Now the point that we want it to go through is actually the midpoint of AB. So that's -4 plus 3 over 2, comma 3 plus 4 over 2. So that's minus half 7 over 2. So y minus 7 over 2 equals -7, x minus 1/2, so it's plus 1/2. Minus 7 over 2. So y equals minus 7x. And you could write this as 7x plus y equals 0. But either of them are fine. 12. Straight line y equals x plus 1 intersects the curve x squared minus y equals 5 at A and B. A lies below x-axis, P lies on AB, such that AP to PB is equal to 4 to 1. Find coordinates of P. And essentially what this is telling us is, okay, you find the 2 points, and the way you'll know which one is A and which one is B is that A will be the one that's got the y being less than 0, a negative y value. And then P lies on AB, so that the distance between P and A is 4 times that of P and B. So y equals x plus 1, and so we instantly substitute that for y. Right, and I've factored that instantly. X equals 3, x equals minus 2. Y equals 3 plus 1, which is 4. Y equals minus 2 plus 1 equals minus 1. That's our negative 1. Therefore, A will be at minus 2 minus 1. B at 3, 4. And now let's say P is at X and Y, we'll say. Y minus 1, which is just positive 1, squared plus X plus 2 squared, as we're looking at, this is our distance of between A and P. That is equal to 4 times the distance between P and B. So that's y minus 3 squared plus x minus 3 squared and y minus 4 squared. And what I would do is I'd just square both sides. And then what I would do Yeah, actually, I think what I probably would have to do here is do a few more things. I'd have to say, okay, m of AB is equal to 4 plus 1 over 3 plus 2, which is 5 over 5, which is 1. Then y minus, and I'll take the points of B, y minus 4 equals x minus 3, y equals x plus 1. And now I know that AB, that equation will be x plus 1. Oh wait, what am I doing? I already... And what I can do is we can do a substitution because we know that y equals x plus 1. And now if we just expand the, this partially, it's 16 times 6 is 96. So 15x squared minus 100x plus 140 equals 0. 3x squared minus 20x plus 28 equals 0. And let's do the quadratic formula. And so we have 20 plus 20 squared minus 4 times 3 times 28 over 6. We get 14 over 3. Or we get 2. Now, one of these is a false solution. Now this is a false solution because if you did, you get 17 over 3, which is 5 2/3, which is greater than 4, and you can't have that. So it has to be 2, and then so y equals 2 plus 1, which is 3. So p is at 2, 3. X minus 2y equals 1 intersects x plus y squared equals 9 at A and B. Find perpendicular bisector of the line AB. Okay, it's a similar question as we had before. Let's just get into it. And this is actually shaping up to seem a bit easier than the previous one. So that's MAB will be 2 plus 4 over 5 plus 7. That's a half. M perpendicular will just be minus 2 because it's the negative reciprocal. Now the midpoint will be minus 7 plus 5 over 2, minus 4 plus 2 over 2. So that's minus 1, minus 1. So y plus 1 equals minus 2, x plus 1. So that's minus 2x minus 2. So y equals minus 2x minus 3. And that's the answer. (14) A. We need to split 10 into 2 parts so that difference between squares is 60. So we want x plus y to equal 10, but we want x minus y squared, x squared minus y squared to equal 60. So y equals 10 minus x. So we had x squared minus 100 minus 20x plus x squared, 60. So we get 20x minus 100 equals 60. 20x equals 160, x equals 8. Therefore, y will equal 2. So the answer will be 2 and 8. We need to just do this in general for any n, so any number, not just 10, and any difference. So we're essentially going for splitting n into 2 parts, differences between squares is d. Right, so we want x plus y to equal n, and then x squared minus y squared to equal d. So, y equals n minus x, so x squared minus n minus x squared equals d, so x squared minus n squared minus 2nx plus x squared equals d. Those eliminate. So you just get 2nx minus n squared equals d. Just move this around to get x on its own. D plus n squared. And you could simplify this to be, well, n squared over 2n plus d over 2n, which this one here will simplify to n over 2. And then for the other solution, you would just do n minus n over 2 minus plus 2n. So that's so that will just equal n over 2 minus d over 2n. So that's it for exercise 1D, the simultaneous equations. Stealth quadratics will be next.